Hello and welcome. Today, we are going to roll up our sleeves and tackle a problem that looks like it was pulled straight from a graduate level final exam. Because, well, it was. We're going to take this tough question about a duopoly, that's a market with just two firms, and we are going to break it down step by step until it's perfectly clear. Let's get right into it.
So here it is, the full question. You've got demand functions, cost functions, talk about market share. I get it. Seeing all of this on one page can be a bit much, but trust me on this. By the end of our time here, you're going to see a clear, simple path right through the heart of this problem. And here's our game plan for today. Think of it as our playbook. We'll start with the basic concepts to make sure we're on the same page. Then we'll walk through all the math, step by step. And we'll even talk about how to write up your answer to get the best possible grade. It's a full-on roadmap from confusion to total confidence.
Okay, first things first, before we even think about touching a single number in that problem, we have to make sure our foundation is completely solid. So let's do a quick refresher on the big ideas that are at play here.
So, at the very core of this problem is the idea of a duopoly. It's just a market with two firms, two major players. And the key word here is influence. What firm 1 does has a direct, and I mean direct impact on firm 2, and vice versa. They're constantly reacting to each other's moves. Next up, we have product differentiation. This is huge. It's the reason why our two firms aren't just stuck accepting whatever price the market dictates. Nope, they have their own unique products, and that means they have their own unique demand curves. If you look closely at the problem's demand function, you'll see that firm 1's price depends on both its own output and its rival's output. That right there is product differentiation in action. And finally, we have the golden rule of pretty much all of microeconomics, profit maximization. It's really intuitive if you think about it. As long as making one more widget brings in more money than it costs to actually make it, you're going to keep making widgets, right? You only stop when the revenue from that very last unit, the marginal revenue, is exactly equal to its cost, the marginal cost. That is our North Star for this problem, MR equals MC. This table is a great way to visualize where our duopoly situation fits in. It's not a monopoly with absolute power over price. And it's not perfect competition, where firms are powerless price takers. It's this really fascinating sweet spot in the middle, where strategy and rivalry are everything. So you've probably seen these ideas before, right? This isn't totally new. Let's quickly connect this problem back to some of the foundational principles you'd find in a classic textbook.
If you're using Mankiw's Principles of Economics, and a lot of you probably are, you'll want to dust off the chapters on monopolistic competition and especially oligopoly. That's the home turf for all this stuff. It's where you'll find the deep dives into strategic interaction and game theory that are the theoretical backbone for the problem we're about to solve.
All right, the foundation is built. You know the theory. Now it's time for the fun part. Let's get our hands dirty and actually solve this thing. Time to dive into the math. Okay, this right here, this is the most important step in the entire problem. We have to translate one key phrase from English into math. The problem states that firm 2 has 1/3 of the market. So what does that mean? It means its quantity, Q2, is 1/3 of the total market quantity, which is Q1 plus Q2. Now, if you do a tiny bit of algebra on that, you realize that if firm 2 has 1/3, firm 1 must have the other 2/3. This means Q1 is double Q2, or flipping it around, Q2 is half of Q1. This single piece of logic is the key that unlocks everything else.
Now we can get to work setting up our main equation. We all know that profit is just total revenue minus total cost, and total revenue is just the price you charge times the quantity you sell. Our big goal here is to get everything into one clean equation in terms of just one variable, Q1.
And here comes the calculus. First, we take that key insight, that Q2 is just half of Q1, and we plug it right into our demand function. Boom. Now our price only depends on Q1. We multiply that whole thing by Q1 to get our total revenue formula. Then, to find the marginal revenue, the extra revenue from selling one more unit, we just take the derivative of that total revenue function. We do the exact same thing for cost. The derivative of the cost function gives us our marginal cost. It's a really clean, powerful process.
And this brings us to the moment we've been building up to, the whole point of all that work. We take the marginal revenue we just found and we set it equal to the marginal cost we found. This is it. This is the profit maximizing condition. This is the economic principle that makes the whole solution work.
So once we have our MR equals MC equation, the rest is honestly just algebra. It's pretty straightforward. we solve that equation for Q1, which is our firm's optimal output. From there, it's super easy to find Q2. Then we can plug both of those quantities back into the original demand function to find the price. And finally, we calculate the profit. Done. And voila! Here are the final numbers all laid out nice and neat. Duopolist 1 will produce 10 units, the price will be $150, and that will give them a profit of $1,000. We also know that Duopolist 2 will produce 5 units. We did it. That's the solution.
Okay, so getting the right numbers is fantastic. But let's be real, on an exam, how you present your answer can be just as important as the answer itself. So let's talk about how you can go from just a correct answer to a truly exceptional one. A top-scoring answer really tells a story. You should start by clearly stating that critical assumption you made about market share. Then, yeah, show your math, but don't just show it. Explain the why behind each step. Why are you taking a derivative? Why are you setting MR equal to MC? Use clear headings, make it easy to read, and wrap it all up with a nice, clean summary. You're showing the grader that you don't just know how to plug and chug a formula, you actually understand the economics behind it. So what's actually going on in your professor's mind when they're looking at your paper? What are they really grading you on? Let's peek behind the curtain and look at the scorecard. Now this is so important. Take a look. Yes, getting the right final number gets you half the points, but look at the other half. 30% of your grade is for showing logical steps, and another 20% is for how clearly you explain the concepts. That means your reasoning and your communication are worth just as much as getting the right answer at the end. Okay, so we have completely taken this problem apart and put it back together. But the learning doesn't have to stop here. Let's talk about what you can do next to really lock in these concepts and become a master. My best advice? Practice. Go find similar problems, but maybe change the cost functions and see what happens. After that, you can level up by exploring other famous duopoly models, like Cournot or Stockelberg. They use different assumptions and lead to different outcomes. And for a real brain teaser, think about this. What would happen if our two firms decided to work together and act like one big monopoly? And I will leave you with this little food for thought. What happens to the market if, all of a sudden, Duopolist 2 gets way more efficient and its production costs are cut in half? How would Firm 1 have to change its strategy to react to that? It's asking these kinds of questions that really elevates you from just solving problems to truly thinking like an economist. Thanks so much for joining me today.